Hello, algebra students. Well, today we're going to be continuing to graph quadratic functions, but these are going to be in standard form today. Recall the other day when we were graphing quadratic functions, they were in vertex form. Now, standard form is what we have written here, and this is actually the more common form that we will see for quadratic functions. A vertex form is very convenient for graphing because the vertex can be found right in the equation when they're in vertex form, right in the function definition. But in standard form, we do have to work a little bit harder to get it. But again, standard form is the more common form where we actually find these equations. So, how do you find the vertex? Well, here's the steps. First, to graph a quadratic function in standard form, you do find the x-coordinate of the vertex. And there's a convenient formula to do that. Negative b over 2a, where b is the x-coordinate, a is the coordinate of x squared. And once you find the x-coordinate of the vertex, you can then find the y-coordinate of the vertex by just plugging that x that you found, that is the x-coordinate, into the function and evaluate it. And that will give you the y-coordinate. And then you plot that vertex, and then plot points on each side of the vertex by going out one and up by the slope, which is a. That's slope in quotes because it's not really a slope, but it can be used to find points in a manner, something like you would use a slope for that. Then you can plot additional points if more accuracy in the sketch is needed. But we're just going to be plotting those 2 points, one on each side. And once you've plotted the points you need, you sketch the parabola. So this will be more clear when we look at a couple of examples. So here's the first one. This is a function in standard form. And the first thing we're going to do is find that vertex, and we start by finding the x-coordinate of the vertex. So remember, the formula is find the x-coordinate by taking negative b over 2a. That's all there is to it. So we'll plug that in this one. So you have negative b, but b itself is negative 2, right? So negative of negative 2, if we want to go ahead and write it down, over 2 times a. And a is the coordinate of x squared, which is 1. So we just calculate this. The numerator is negative of negative, so that's just positive 2, and it's over 2, so that is 1. So that's the x-coordinate of the vertex. And the y-coordinate of the vertex is, well, you want to know what is the y value when x is 1. And that will be the y-coordinate of the vertex. So plug in 1 for x and find out what y is just by evaluating the function at that number, at that value for x. So we put in 1 for x, so it's 1 squared minus 2 times 1 plus 3. And calculate that. 1 minus 2 plus 3, and y equals 2. So we have our x-coordinate, we have our y-coordinate. So the vertex is, the x-coordinate was 1, y-coordinate is 2. 1, comma 2. Okay. So we've got that, and now we can plot it. So it's right there is the vertex. And now we look at A, which we can call the slope in quotes again. A is the coefficient of x squared. It's the number multiplied by x squared, so it's right here. Well, it's 1 in this one, right? There's no number there, so it's 1. So we're going to go to the right by 1, and then we go up by that A, which is 1. And that gives us a point. We go to the left one, and we go up by A. 1 again over there. And then we can sketch it. And if you want more accuracy, you could go ahead and plug in 4, let's say, a couple over. And then see on the left, so that would be a total of 1, 2, 3 from the vertex itself, right? If here's the vertex at 1, so 1, 2, 3 gets us to 4, so you would go to the left from there. 1, 2, 3, and plug that in. 2. Plug in for x. See what you get for those values and plot them, but we're not going to do that today. So we have enough, and we just sketch this the way we think it goes. Remember that it's curving, and just remember the shape of a parabola, so something like that. Okay, so let's go to the next one. Somewhat similar problem. Sketch this. Notice coefficient of A is negative this time, so this is going to open down, right? So let's see, let's calculate the coefficients of the vertex first. We use the formula that we just learned, negative b over 2a. So let's see, that in this case b is 12, so that's negative 12 over 2 times a, and a is negative 3. So that's just going across here, negative 12 over negative 6, so that's 2. Okay, now we'll find the y coordinate of the vertex. Just plug in that 2 in for x, so negative 3 times 2 squared, okay, plus 12 times, put in 2, minus 8. So let's see, let's simplify that. 2 times 2 is 4. Negative 3 times that is negative 12. And that's plus 24 minus 8. Y equals positive 12 minus 8, which is 4. Okay, that is our number, so the vertex is just 2, 4. The x value that we, the x coordinate of the vertex we said was 2. Plug that in and calculate what y is when x is 2, and that's 4, and there we have it. So now we can plot that vertex and go from there. 2, 4, looks like here. And a is negative 3, so we'll be going down 3, which is consistent with the fact that we know when a is negative, the parabola opens down. So we kind of call it a slope to get these other points. So when we go over 1, we're going to go down 3. Over 1, down 1, 2, 3. It's right there. Okay, and over 1 to the left, and down 3 gets us to there. So Our vertex is 2, 4, as we said, and we also have points here at 1, 1 and 1, 3. Okay. So now we can draw this. We've got enough points to sort of sketch it. Not a real good at this. That's not completely terrible. Okay, one more try. Okay, and it's tricky to me to get this rounded sort of at the end. It's not by any means a like absolute value where you have a sharp angle there, but it's curved. Okay, so that's a couple of examples. So you'll have some homework to do on these. Let me know if you have any questions, and that is all.